On this video, we look at the atomic number, the atomic mass number, and isotopes. The atomic number, represented by the symbol Z, indicates the number of protons in the nucleus of an atom. It determines the chemical properties of an element, and elements in the periodic table are arranged according to the atomic number. A neutral atom has an equal number of protons and electrons. Remember, I did say this in chapter 1, and it has a net charge of 0. Therefore, the atomic number is equal to the position of the element in the periodic table. It is equal to the number of protons in the nucleus, and it is equal to the number of electrons around the nucleus of a neutral atom. So if you see the atomic number in your periodic table, it represents the number of protons and electrons in that element. What happens then if an atom loses one or more electrons? It will have more protons than electrons, and therefore it will have a net positive charge. Remember, I did say this again in chapter 1, that a neutral atom has equal number of protons and electrons. So if it loses an electron, it makes sense that it becomes positively charged, because it's going to have more protons which are positively charged than electrons which are negatively charged. Metal atoms are the ones who lose their valence electrons in a reaction with nonmetals, and they form cations, which are positive ions. The ionic charge will then be equal to positive the number of electrons donated. For example, if an atom donates 1 electron, its ionic charge will be positive 1. And the ionic charge is also equals to positive the group number that is in main group elements. That is for group 1, 2, and 3 elements. So if an atom is in group 1, then its ionic charge will be positive 1. An example of this is sodium. Sodium has an atomic number of 11. Therefore, neutral sodium atom has 11 protons and 11 electrons. And if a sodium atom loses an electron, it will have 11 protons, but it will have 10 electrons. Therefore, it's going to be positively charged, because now it has more protons than electrons, and the net charge will be positive 1. What happens if an atom gains an electron or electrons? It will have more electrons than protons, and therefore will be negatively charged. And nonmetals are the ones who accept electrons and form negative ions or anions. And the ionic charge is going to be equal to negative the number of electrons gained, which means that if an atom gains 2 electrons, its ionic charge is going to be negative 2, and it's also equals to the group number minus 8. So from group 5 to 8, if you remember, the ionic charge is equals to group number minus 8. An example of this is chlorine atom. Chlorine has an atomic number of 17, and neutral chlorine has 17 protons and 17 electrons. And if chlorine gains an electron, it will have 17 protons but 18 electrons, which makes sense that it will become negatively charged and will have a net charge of negative 1. This is why some atoms prefer to donate electrons and some prefer to lose electrons. And if you look at my 2 examples that I've made for chlorine atom and sodium atom, you will notice that the number of protons do not change in both these examples, but the number of electrons is the one that changes. Let's look at the atomic mass number, which is represented by the symbol A. It indicates the number of protons and neutrons, collectively together called nucleons. So atomic mass number is equal to the number of protons, which is represented by the symbol Z, plus the number of neutrons, which is represented by the symbol N. Let us now look how to calculate the number of neutrons in atoms. We know that in the periodic table we get the number of protons, and we're also given the number of neutrons. So how do we then, no, we're given the atomic mass number. So how do we then get the number of neutrons from these two, from the atomic mass number and the atomic number? So neutrons will be calculated as the atomic mass number minus the number of protons. The atomic mass number we get on the periodic table, so for hydrogen it is 1, and the number of protons we also get from the periodic table, and for hydrogen is 1. So the number of neutrons for hydrogen is 0. Then for the sodium atom, again, number of neutrons is equal to the atomic mass number minus the atomic number, or number of protons. That will be equal to 23 minus 11, because we have 11 protons in the sodium atom and we have an atomic mass number of 23 from the periodic table, which gives us 12. You should know how to do these calculations for exam purposes. Let's move on to isotopes. What are isotopes? They are atoms of the same element with the same atomic number but different atomic masses, namely the number of neutrons. So they have the different number of neutrons, but they have the same atomic number, meaning that they have the same number of protons. As I told you, that the number of protons doesn't change. Some elements occur naturally as the mixture of different isotopes. Such elements still have the same number of protons and electrons and thus the same chemical properties, but they have the different number of neutrons. So which means that they will have different number of neutrons as well. Because remember I said that neutrons are neutrons plus protons. How do you calculate the average atomic mass for isotopes? We use the percentage abundance or incidence of the different isotopes to calculate average relative atomic mass of an element. Let's look at an example of chlorine. We are told that chlorine occurs as the two isotopes chlorine 35 and chlorine 37. Out of 100 chlorine atoms, plus or minus 75 will be chlorine 35 and plus or minus 25 will be chlorine 37. And then we are told that their percentage abundance is given as 75.5% and 24.5% respectively, meaning that the chlorine 35 has a percentage abundance of 75.5% and chlorine 37 has a percentage abundance of 24.5%. How do we calculate our average atomic mass then? We say the average relative atomic mass of chlorine is equal to the percentage abundance multiplied by the number of nucleons, which is 35 for the isotope with an abundance of 75.5, and then we multiply those two and then we sum them to the product of the percentage abundance of the second one, which is 24.5 multiplied by 37, and then we divide all that by 100, because the 75.5% and the 24.5% both add up to 100. Then we get a final answer of 35.5. Let's move on to standard notation. The atomic number, which is also the number of protons, and mass number are indicated using a standard notation. Standard notation shows the chemical symbol, the atomic mass number, and the atomic number of an element as follows. We write the chemical symbol like that, so that big X represents the chemical symbol. Then we write the number of neutrons and the number of protons. It doesn't really matter where you write the number of neutrons and the number of protons. You can write the number of neutrons at the bottom and the number of protons at the top, but you just need to know that the number of protons will always be lesser than the number of neutrons. For example, the iron nucleus has 26 protons and 30 neutrons, so it will be denoted as Fe, 56 at the top and 26 at the bottom. Then you know that the 26 represents the number of protons. So the atomic number is 26, the mass number is 56, and number of neutrons will be 56 minus 26, which is 30. So remember that it doesn't matter where you write your number of neutrons and your number of protons. What matters is that you know that the number of protons are always lesser than the number of neutrons. Here's an example. Use standard notation to represent sodium and give the number of protons, neutrons, and electrons in the element. First step is to give the element symbol, which is Na. Our second step is to find the number of protons. How do we find the number of protons in the periodic table? It is 11, and then we write it at the bottom next to our element symbol. So it is preferred that you write your number of protons at the bottom. Then you find the number of electrons. Number of electrons for a neutral atom is equal to the number of protons. So automatically, if you have the number of protons, you will have your number of electrons. Then you find your atomic mass number. Where do we find that? Again, in the periodic table. Then we find that it is 23. We move on to step 5, where we work out the number of neutrons. How do we work out the number of neutrons? We say our atomic mass number minus the number of protons, which in this case is 23, minus 11, which gives us 12. Then finally we write our answer. So this is how you determine your standard notation. This is the table showing the notation for different isotopes. I suggest that you familiarize yourself with the different isotopes, but you don't really need to, you just need to know that they have the same number of protons. That's what you need to know. And then you need to remember how to calculate your relative atomic mass. Let's do one more example on calculating the average relative atomic mass of 3 isotopes of magnesium. We have our table here with the 3 isotopes. 1224 magnesium with an abundance of 80%. We have 1225 magnesium with an abundance of 10%. We have 1226 magnesium with an abundance of 10%. How do you calculate our average relative atomic mass? We say 80% multiplied by 24, which is the number of neutrons for our first isotope. And we say 10, and then we sum that with 10 times 25, and we sum that to 10 times 26, and then we divide all that by 100, and then our final answer is 24.3. That is it on this video. On the next video, we're going to look at electron configurations.